All right, let's look at one final problem. And this one, just to change it up a little bit, I'm going to show you how to write these when they are in exponent form. So if it's in exponent form, like x to the 1/3, and g of x is equal to 1/3 of x to the 1/3 power minus 6. So we've been talking about things under radicals. So I want to go ahead and change this to my radical form from exponent form. And remember that we can switch back and forth between the two using one of our properties. And so we're going to use the rational exponent property to convert the exponent, because we want to change that to a radical, because that's how we know how to deal with things, is when they're under a radical. So if we use the rational exponent property, that says that our base is still here, but now our base becomes our radicand. Our denominator is the index, and the numerator is the power. Okay, we don't usually write that one, so this could be rewritten as just cubed root of x. All right, so let's change our g of x. Our 1/3 that's out there in front still stays as 1/3 out there in front. X to the 1/3 power, again, is the cubed root of x. And then we have a minus 6 that's outside of the exponent. It's not like in parentheses with x, so it's outside, so we will keep it outside. So let's take a look at our actual transformations now. We've got a 1/3 out here in front, so it's outside of the radical, so that means it's going to be vertical. When we're vertical, fractions shrink, so we have a shrink by 1/3. Shrink by 1/3. And then the other thing that we have done from our parent function is we have this minus 6 outside the radical. It's just kind of hanging out there in the back. So that means it's a vertical translation, because it is not inside with x. And that's going to go down by 6. Negative 6 sends us down. All right, so we have shrunk vertically by 1/3. That means that our graph is going to start becoming more horizontal. It's not going to be quite as fat. And then our center point in this case has moved from 0 in the y direction down to -6. So let's take a look at what that looks like on Desmos. Again, parent function in red and transformed function in blue. You can see that it is a much flatter graph. It's not nearly as fat, if you will, as our original one. And so that has changed by a factor. I'll shrink by 1/3. And you can see that our starting point, or our center point in this case, has moved from 0, 0 down to 0, -6, just as we expected, a translation down by 6. We said that our center point was down at -6, and we have a fairly flat graph. So it's still kind of an S shape, but it's pretty flat here, something like that. And again, our center point being 0, -6. All right, we have a cubed root function, or a 1/3 exponent, and our original domain and range was all real numbers, and that doesn't change just by moving our center point, or by shrinking or expanding our graph, shrinking or stretching. So our domain is still all real numbers, and our range is still all real numbers. It's going to take us longer to get to positive and negative infinity in the y direction. Our graph is much flatter, but eventually, if you go far enough in the x and y, or in the x direction, left and right, you'll get there.